we are now going to graph inequalities with vertical or horizontal boundaries. So we're going to start with y is greater than 2. And so we know that we graph this by pretending it's an equation, y equals 2. So we pick our dot, and we know it's a dashed line because it's not an or equals. So we put our horizontal line in, just like we would if it was y equals 2, but it's dashed. And then we pick a point. I'm going to pick this one. I'm going to pick 0, 3. Any point would work, and I plug that in, and I get 3 is greater than 2, which is true. So I shade the side of the line that has that, which is this upper portion. So here I shade it in, and I'm done with the problem. I could have picked any other point. Had I picked, say, 4, 5, then I'd still see that 5 is greater than 2, which is still true. If I'd picked minus 3, minus 7, I'd have minus 7 greater than 2, which is false, so I wouldn't shade this point here because it's too low, whereas this one worked or this one worked. So I can pick any one point, and based on whether it's true or false, I know whether it'll work or not. The next one that we want to look at, suppose we look at y is less than or equal to minus 3. Well, that's the same as graphing y equals minus 3, and it's solid this time. So we come down to minus 3, and we draw our solid line across. And since it's a less than, we can pick points. If I pick 0, 0, it's a good point to pick. Is 0 less than or equal to minus 3? No, that's false. So I don't shade where the 0, 0 is. I have to cross the line and shade below. Now notice, if all I have is a y, and that y is completely solved for, a greater than means above, and a less than means below. Well, that handles vertical or horizontal lines. What about those vertical ones? What about x is greater than or equal to negative 2? Well, this means our line is the same as x equals negative 2. So we come back, and it's a solid because it's an or equals. We draw our line in, and we want to know who's bigger. So let's pick 0, 0. Is 0 greater than or equal to minus 2? That's true, so we shade the sign that the 0, 0 is on. Notice that it's everything on this side. No matter what the y is, as long as the x is bigger than negative 2, it's true. Well, that also happens to mean, now that we've set this up, that if we have an x by itself, a greater than means it's to the right when we shade. And a less than, such as x is less than 5, means it's to the left. So we start at 5, and we draw on a dashed line since there's no or equals part. And I don't even need to test a point. I just know x is less than 5 means I shade less than 5, and that's this stuff over here. And that's graphing inequalities with a vertical or horizontal boundary.